and when it is assigned to upper sequence and print upper sequence, ATCG will be printed on the screen here. So in this case, dot upper, it is similar to print and length functions, similar to print and length. Print and length will work for the data whatever you give, whatever the data you give, whereas this dot upper, it is called as a method. It is only applicable to this sequence data or string data, that is ATCG in this case here. So methods are applicable to data types, whereas functions are general to everything here. And I want to convert uppercase to lowercase. I can use a function called as dot lower method, the method called as dot lower method, and my ATCG will become print lower sequence. It will become ATCG here. In Python, you have around tens of methods are available, like upper and lower. So all these methods can be learned, or what are the different kinds of methods can be used for a given data type using a function called as a dir, or directory function. In directory function, you need to say, suppose I want to say what are the methods applicable to for this one. Simply I type dir sequence. Output will be printed on the screen with different method names: upper, lower, find, count, and so on. So we'll see these things in coming sessions while we do the programming. So we are at the task of just learning the basic concepts of Python strings here. So moving to the next methods, we have strip method. The strip method, it will remove the any leading and trailing spaces from a string. When you give string input to your sequence, suppose in this case you take ATCG. So in ATCG, there is a leading space, a trailing space, and a leading space in the sequences here. So this can be removed using string method. You need to say sequence dot strip. Stripped sequence equal to sequence dot strip. These things will be removed, and the output will be ATCG on the screen here. And you can replace a simple character with another character. So we know that the difference between DNA and RNA, when you write on the sequence, so excuse me, when you write on the sequence DNA and RNA, ATCGT, THT, it is a DNA sequence. And when you say RNA sequence, it will be AUCG, UU, AU in RNA sequence and a DNA sequence. So if you are given a task to convert a DNA to RNA sequence, simply you have to replace T with U. So that can be done using a method called as a replace method. So sequence equal to ATCG GTA, new sequence equal to sequence dot replace T in quotations, comma, U in quotations, print new sequence. On the output you have AUGGG UA, and you can convert a given sequence into given string into list of nucleotides here. So there is a method called the split method is there. So in this one I have A comma T comma C comma G. So this is a string. You understand that it's a string. So A is first character, comma is second character, T is third character, comma is fourth character. So it is a sequence here, and I want to split this one into separate entities A, T, C, and G. The split method, it will do operation for me, but I need to say where I want to split. So I want to split all the commas, wherever comma is there. I want to split that one into separate sequence here. So print split sequence, it will provide me ATCG on my screen here, and I can join different individual characters or lists of characters into a simple string here. So the method available is join method. To use the join method, I need to say the joining thing here, joining thing, which should be in the quotations, and join followed by the variable which stores my sequence of characters or my elements that should be joined here. So basis equal to atcg sequence dot join basis, print sequence. It provides the output as atcg, a dash t dash c hyphen g here. So if I don't give anything, the output will be atcg, and I can find out the position of a given character in my given DNA sequence. So if I want to find out the location of first G, I have to say sequence dot find G. So the output will be 3. At third position, the output is there. As I told you, in computer science, the numbering starts from 0. So here the position is 3. The actual position may be 4. What it prints me? It prints me the computer science position here. And to count how many numbers of G's are available in my sequence, I have to use the count method here. So sequence atcg ta. So count equal to sequence dot count G, print count. And there are several methods are available with Python strings. So you can check for the case whether a sequence is starting with something or ending with something. Simply you need to say sequence dot starts with A or sequence dot ends with T. And whether given string is alphanumeric, is it a alphanumeric or not? Is it digit? Also you can find out. Dot is alpha, dot is digit. These two methods will tell you whether the type or identity of your given string here, and it can tell you whether the sequence is uppercase or lowercase. You can use is lower and is upper, is lower or is upper. Like hundreds of not hundreds, tens of methods are available with your Python strings. So to check that one, simply you have to use a function called as dir function. So when I say sequence atcg cggta, I need to say dir sequence. It lists all the methods available with my DNA string atcg gta. So this is about Python strings here. So Python strings very much useful or very much handy in bioinformatics. So because in bioinformatics we do sequence alignments, and we'll try to do multiple sequence alignments, construct phylogenetic trees, and for all these things the basis is the DNA sequence. So thank you very much for listening to this session. So we'll talk about lists in next session. Thank you.